Hello. Welcome to another snow day lesson. I decided to switch up the order that I'm going to teach things so that we could do this lesson, because the lesson that is actually next could not be done through a video, and this one can. So I'm switching up the order a little bit, but here we go. Alright, so buffers are aqueous solutions that work to maintain the pH of a solution. So if you add an acid or a base to a solution, a buffer will work to maintain the pH. Okay, and they do this by being able to neutralize an incoming acid or base, which we're going to see how that works in a second. So this lesson focuses on how you make a buffer, or what is used to make a buffer. And today we're going to learn the first way to make a buffer. There's a second way that we're going to learn at the very, very end of this unit. But we're going to focus on the first way, and then at the end of the unit, you have to learn something else to learn the second way. So that's sort of the consequences of skipping to this lesson first. So to make a buffer, okay, you dissolve a weak acid with its conjugate base in a solution. Or the reverse, which is pretty obvious. You can dissolve a weak base with its conjugate acid. Okay, now the question is, why does this work? Okay, well, let's say we have a buffer composed of HF, this is a weak acid, okay, and a salt of its conjugate base. So remember, the conjugate base of HF is F, so it's a salt containing the conjugate base. So like I said, we have HF, and we have its conjugate base. That makes a buffer. Why does this work? Okay, well, let's say you have this solution that's composed of HF and NaF, and you add a base to it, okay? What can happen is the acid, the weak acid, HF, can react to neutralize the NaOH as long as there's enough HF there. Okay, there has to be enough of there. If there's more NaOH, the buffer won't work anymore. Okay, but if you put base there, the HF can react with the NaOH and neutralize the base, producing salt and water. Water and salt. Similarly, on the opposite side, let's say you add acid. Let's say you add HCl. Well, the conjugate base then can neutralize the HCl as long as there's enough F-. So if we see here, HCl will react with NaF to produce HF and NaCl to neutralize the production of acid. So to summarize, a buffer can be composed of a weak acid and its conjugate base. And why they work is that the weak acid can neutralize any base that comes, and the conjugate base can neutralize any acid that comes into the solution to keep the pH the same. Now, if you remember back in AP Bio, and so to those of you who were not in AP Bio, you'll also now be able to understand this. We talked about pH, but pH buffers in the blood. And so in your blood, you have, this is bicarbonic acid, and this is bicarbonate ion. Okay, and these are in your blood. This is a weak acid, okay, and this is its conjugate base, okay, and they're in the blood. So this weak acid and this conjugate base can work to maintain the pH of the blood, and the pH of the blood is maintained around a little bit above 7. All right, so if we take a look here, this is the weak acid. If OH comes into the blood, it can neutralize the OH, producing water and salt. Well, here in this case, the conjugate base. Okay, and then if acid is added to your blood, or blood gets too acidic, and that happens sometimes when you breathe excessive carbon dioxide into your blood, or release excessive carbon dioxide into your blood, the conjugate base can react with the H+ and neutralize it. Okay, so again, to summarize, to make a buffer, you need a weak acid and its conjugate base. The weak acid will neutralize any base that comes into the solution, and the conjugate base will neutralize any acid that comes into the solution. So here we have another example of a buffer, except here we have a weak base. So ammonia here is a weak base, and this is its conjugate acid, or NH4 is its conjugated acid, and it's usually put with usually in a salt. So we have chlorine. Chlorine is a spectator ion, doesn't participate in the reaction. So again, you can also have a weak base and its conjugate acid to produce a buffer. Okay, and the question is, which equations are describing how to maintain the pH? Okay, so if we take a look at the reactions, okay, we know that to maintain the pH, this is the acid, NH4 is the acid, it will react with OH and neutralize it to produce NH3 and water. So that's one reaction that's occurring in the buffer. Okay, the second reaction that's occurring with in the buffer is number 5, because we have the base, or the weak base in this case, reacting with H plus and neutralizing it to produce NH4 and water. So here, reactions 2 and 5, okay, those are the ones that are working to maintain the pH in this buffer that's composed of NH3, a weak base, and its conjugate acid NH4 in a salt. Okay, so if we were in class right now, I would stop and I would ask you to do this, and then I would show you the answer. So I would pause the video and do this. So the question says, show and explain how a solution of HC2H3O2, which is acetic acid, and lithium acetate, this polyatomic ion is acetate, how would they act like a buffer? I should say how it would act like a buffer. I don't know why I didn't finish. So it's just to show and explain how this solution would act like a buffer. Okay, but then I can't finish what I'm writing. So again, this is a weak acid. Acetic acid is a weak acid. And then here we have its conjugate base in a salt. So again, this can act like a buffer. So if we add some base to this solution, to this buffer solution, what's going to happen is the acid, acetic acid, is going to come and neutralize it and produce water and salt. Okay. Now if we add acid, if we add HCl, the conjugate base is going to come and neutralize it, getting rid of the H plus. Okay, now, it's important to realize that Li here is a spectator ion. Okay, if we wrote the net ionic equation, it would get crossed out. Okay, so Li here is the spectator ion. It is not participating in the reaction. So here we have a set of solutions when you want to know which ones can act like a buffer or not. So we have to see what's in them. So here we have a strong acid and a salt. What is it? And Cl is its conjugate base, but we can't have strong acids because Cl can't act like a base. It's pathetic. So this will not act like a buffer. So no for this one. For this one, weak acid. And then here we have a salt, and this is its conjugate base. So a salt of its conjugate base. So this one, all good, acts like a buffer. So this one we have sodium hydroxide, which is a strong base, and lithium hydroxide, which is a strong base, so this is not going to act like a buffer. Here we have, this is, I can't think, this is nitric acid, and this is which is strong acid, and this is calcium hydroxide, which is a strong base. That doesn't meet the qualifications for a buffer. So this is a weak acid. And then we have its conjugate base in a salt, so this one will work. And then if we look here, we have a weak base, and then we have its conjugate acid in a salt, so this one will also work. So the ones that can act like a buffer here are 2, 5, and 6. Okay, now, we're going to talk more about this on Tuesday, about like what buffers to use at certain pHs. But this is a oversimplification. It's true, but there's a big range of pHs that we're going to look at. But buffers with weak acids, okay, so if you have a buffer that has a weak acid in it, okay, they buffer at acidic pHs, or pHs below 7. So there's a range where they'll work, and we're going to talk about that tomorrow. Not tomorrow, today is Sunday, so Tuesday. And then buffers with weak bases, as a sort of the component, they buffer at basic pHs, or pHs above 7. And again, some buffers will work better at pHs of 4, some will work better at pHs of 10, and we're going to be able to calculate those on Tuesday. But this is just a sort of a simplification for now. Okay, so last sort of thing, and don't worry about the amounts right now. So the amounts right now don't matter, okay? Just look at sort of what's in it, okay? So if we take a look, it wants to know which one will be a buffer, and if so, what will the pH of the solution be? Where will they be buffering? So this is a salt, and this is a strong acid. So this does not work. Remember, we need weak acids. This does not work because NO3 is pathetic. It doesn't work as a base. Okay, calcium acetate, which I don't know why this is written in words, but calcium acetate is hold on, let me type this out. So I typed out calcium acetate and acetic acid. So this is acetic acid, and then we have its conjugate base in a salt. So this will be a buffer, and again, we're starting with a weak acid, so it will buffer at a pH below 7. If you look at this one looks a little weird. So this is a weak base. Anything that has NH in it is a weak base. And then if we take a look, what do we have? Well, we have this here is its conjugate acid in a salt with NO3. So this will work as a buffer. And again, since you're starting with a weak base, it will buffer at a pH above 7. And then here, last but not least, this is a strong base, and this is a salt. This will not be a buffer. This one will work. So the ones that will work will be 2 and 3. This will buffer at an acidic pH, and this will buffer at a basic pH. So we have one more question here, and then one more sort of summary thing at the end. And it says, so which of the following conjugate acid pairs will not function as a buffer? So if we take a minute and look at them, we have weak acid, conjugate base, good. Weak acid, conjugate base, also good. Strong acid, conjugate base, not good. Okay, NO3, right, is pathetic. It won't be able to work as a base to help buffer. So this one here will not work as a base. So does our phone will call us out? Not good. This is pathetic. Can't function as a base to help the buffer. Okay, last other question, and we're done, and then you're going to do some practice questions. So in an NH4 plus Na3 buffer, what concentration changes will occur if a small amount of OH is added? So if we look at the reaction that occurs, this is a base. OH is a base, and it's going to react with the acid. So NH3 is going to react with OH to produce water and NH4. So if we take a look, this is going to use up some of the acid. So NH3, right? That's going to go down. Now, when the OH reacts with the NH3, it produces NH4. So that's going to go up. So if we look at sort of where we are, the NH3 we said is going to decrease. So that and the NH4 is going to increase. So we're in here. Okay. Now the question is, what's going to happen to the pH? Now I know we said buffers maintain the pH within a range. So it may increase slightly or decrease slightly. But if you look at this reaction, we're producing a base. So even though the buffer is going to maintain the pH, because we're producing a base in this neutralization reaction here, a weak base at that, though, the pH may increase slightly, again, within a range. We're going to talk about the range that buffers maintain Tuesday in class. So here, the answer here, this one would be C, or 3, based on sort of how this reaction shifts when you add OH. All right, so I will see you on Tuesday.